Hey guys, it's Austin. Grant can't be with us here today right now, so it's just me. So right now we're doing a t-interval for difference in means problem. Let's get started. So right here we have our problem. I'll give you a second to read it, and then we'll continue. Alright, well, if you didn't finish, pause the video and you continue reading. But, I'm going to start off right here. We have our summary statistics. Um, we have a variable, number, mean, and standard deviation. And we have the northern side and the southern side. Alright, let's move on. So, this is a state plan do conclude problem. So we want to estimate the difference of means between dBH of trees in the northern and southern halves. The null hypothesis is mean 1 minus mean 2 equals 0. The alternate hypothesis is mean 1 minus mean 2 does not equal 0. Mean 1 equals the true mean dBH of all trees in the southern half of the forest, and mean 2 equals the true mean dBH of all trees in the northern half of the forest. So we go to the plan, and so if conditions are met, we'll construct a two-sample t-interval for mean 1 minus mean 2. We have random, normal, and independent conditions that should be met. For random samples of 30 trees, each from the northern and southern halves of the forest, came from the data. For normal, sample sizes are greater than or equal to 30, so CLT applies. Since CLT applies, the sampling distribution is approximately normal. If you don't know what CLT or central limit theorem means, it's right here. You can read that. Independent. We have two independent, simple random samples from the northern and southern halves of the forest. Since sampling without replacement was used, the sampling distribution has to be at least 10% of the population. 10 times 30 equals 300 trees in each half of the forest. Moving on. This is the do part of the state plan do conclude problem. The formula for a confidence interval is right here. Remember S is the standard deviation of the sample. We have all the information except the T-star, and to find the T-star, we want to go to the confidence level C page in your booklet. You need to know your degrees of freedom and your confidence level. Our degree of freedom is 29, and our confidence interval is 95, which gives us a 2.045 T-star. We got our degrees of freedom by the smaller of N1 minus 1 or N2 minus 1. It's 30, N1 equals 30 and N2 equals 30, and 30 minus 1 equals 29, so that's where we get our 29, and we are using a 95% confidence interval level in this problem, so you just add up and it's right there. If you zoom in right here, that's all the information right there. But you can make errors when you put that into your calculator, so you can do it, you can just let the calculator do everything. So right here, this is how you put it into the calculator. First, you would click Stat, a button on the calculator, go over to Tests, scroll down and click on 2-SAMPTINT, click on Stats for input, then put in the information listed below right here. Put that information in exactly as said. Make sure your C level is 0.95 and you have no clicked for pooled. and then the last button should be calculate, and click enter. For this problem, we're using an alpha of 0.05. The calculator gives us a degrees of freedom of 55.73, and our confidence interval right there is 2.5728 to 19.087, and that's the do part. Lastly, we have the conclude part. This is where we interpret what we did. We are 95% confident that the interval from 2.57 to 19.09 centimeters captures the difference in the actual mean DBH of the southern trees and the actual mean DBH of the northern trees. Since 0 is not in the interval, then we reject the HO. Remember, never accept the null hypothesis, either reject or fail to reject the HO. Thank you, and thanks for listening.